Here we are again in the Enterprise Security class, and we're up to Chapter 5 in the textbook. We are through the halfway point when we finish this chapter. The title of this chapter is Implementing and Maintaining a Secure Network. And the focus of this chapter is going to be the process of hardening. Hardening is, if you look in the textbook, it tells you that it's the process of reducing or eliminating weaknesses, securing services, and attempting to make your environment immune to attacks. Generally, when you harden, what you're doing is you're working with software components. It can be your operating system, obviously, as a base, and then it can be any applications that you have running, or in the case of Microsoft servers, roles that you run, such as an email server or file and print services or FTP, DNS, DHCP. All of these can be hardened. It's a good idea when you're in charge of either workstations or servers to do an internet search on best practices for running particular programs in terms of security. If you're running Server 2008, Release 2 has embedded best practice analyzers for almost every component of the operating system. You run the best practice analyzer and it will come up with a checklist of things that it suggests you do in order to increase your security. And the nice thing about that checklist is if it's not implemented, it comes up and tells you that, but it also gives you references so that you can take the necessary steps to implement that security. Like I said, that's something that you'll find in R2. It's not in the base release of Server 2008. One other thing that you can look at is the Microsoft Baseline Security Analyzer, and I know that several of you have mentioned that in your Phase 2 implementation guidelines. All of those are good practices for you to follow. The first subsection of this chapter is entitled Overview of Network Security Threats, and the author begins the discussion by giving you background information on the CERT Center. That's CERT, and that is maintained at Carnegie Mellon University. This is a world-renowned resource, and they give you a couple of web links that you can follow, and they maintain information about network attacks. So that may be something that you just want to poke around at and take a look. The book does discuss a couple of different ways that you can assess your own vulnerability, and you can either do this yourself or you can pay a company to actually perform these tests for you. A penetration test does what the name implies. From the outside of your network, someone will attempt to get through your router, get through your firewall, get through your intrusion detection systems. Whatever you've got in place, this person or company is going to try and break through your security. You can also do something that is a little less invasive. It's called a vulnerability assessment. The focus here is not so much hacking into your system, but doing external scans just to identify where some trouble spots might be. A real common type of vulnerability scan is just a port scan to see what ports are listening. And they give you some information about some free software, and again, it's pretty easy to do an internet search on some of these topics and find all sorts of utilities. You can also find companies that will perform this testing for you. In the section entitled Security Baselines or Defining Security Baselines, the idea here is similar to what you would find as a performance baseline when you're actually looking at how your hardware runs. A performance baseline will measure certain aspects of your system, measure CPU utilization, memory, paging, that sort of thing, and so you know what your standard operating environment is. When you define a security baseline, you're not necessarily scanning your system or establishing what things look like when you're not under attack. Rather, what you're doing is you are setting certain levels of security that you plan to implement. There is a whole list of levels 1 through 7 listed in your textbook, and these are evaluation assurance levels, or EALs, and they go from 1 to 7, 1 being the lowest and 7 being the most stringent. If you look through this, and you can also do internet searches on this, you'll see that the middle of the pack, which is EAL4, is generally the one that commercial sites want to maintain. Depending on how much security you need in your particular environment, you could go higher or lower. I don't know if it was here in this chapter, but I was reading something that said 5 minutes after you've connected a device to the internet, it's already under attack. I always think it's a good idea to kind of err on the side of being overprotective just because the threats are out there and they're not going to go away. And if you happen to do any searches on the internet, you'll see that most of the popular operating systems today are EAL4 or 4 Plus certified. And this includes Vista, Windows 7, Server 2008, Server 2008 R2, and there are versions of Linux and Red Hat as well that are all at that certification level. In the next section, Hardening the OS and the NOS, or the Network Operating System, the book makes a really good point. Any network is only as strong as its weakest component. So keeping this in mind, you really want to make sure that you don't leave things exposed unnecessarily. The first thing that they talk about in this particular section is configuring network protocols. We covered those in Chapter 4, and we talked about NetBIOS, we talked about TCP, we talked about IPX, SPX, and then we also talked about AppleTalk and a few other things. Make sure that you're not running any unnecessary protocols. The textbook takes you through a couple of screenshots of what network bindings look like in an XP system, and it really isn't much different for Vista or Windows 7 or Server 2008 or Server 2003. Here we have an example of NWLink, which is Microsoft's proprietary version of IPX SPX. And I think they're just pointing out that at this point we've got NWLink NetBIOS, we've also got NWLink IPX SPX, and so we've got all three of those protocols running. And unless there's a business need for that, go ahead and disable those. Moving past protocol controls and just going to the operating system, they've got a very brief discussion of hardening Microsoft Windows Vista. One of the things that you'll see in Vista and Windows 7 is user account control, and you actually run into a version of this in the server environment as well. This is a real headache for a lot of administrators. The user account control theoretically is a great component because anytime there is a significant potential change to your operating system or OS related files, it stops and asks you if you really want to do that. I think this can prevent a lot of malware installations on your computer because if you're prompted anytime something like this happens, if you happen to know what's going on, you can answer correctly and maybe prevent this. What I'm seeing is that people just blindly click through it anyway, so it's just something that people ignore at this point. It also makes it pretty difficult to install certain programs just because you need to be in administrator mode, and it takes some trial and error to figure out if you either have to elevate permissions or if you have to actually log on as a different user with a different permission level in order to install stuff. The chapter does have a section on hardening Windows XP, and I think at this point you're not going to see a whole lot of XP environments, especially over the next couple years. I think they're all going to be pretty much phased out, especially since Microsoft is dropping support for XP. They do happen to mention that you can run the performance monitor and look for excessive CPU utilization. I guess that's something that you can do. If you really suspect something, you can go ahead and just start the task manager and get that information as well in real time. But if you do want to do some tracking and get historical information, then you can go ahead and use that performance monitor. The next section moves into servers. Apparently Server 2008 was not around when they were finishing up this chapter of the book. I think this must have come out, they were probably working on the final drafts of this in 2008, and that's when Server 2008 came out. So they tell you about Server 2003 instead. The textbook lists several of the security improvements that were introduced in Server 2003. And then if you've taken either of the server classes, we discuss a lot of the different security enhancements that came out in Server 2008. It's something that they're continually working on. They mention here securing the web server. In this case it's IIS 6. IIS 7 has even more security and a lot more things are built into it. I think what you'll see with the operating system is that overall it's a lot more modular and granular. If you install IIS, you've got, I think, around 40 different things that you can pick and choose whether you need that as part of your base implementation. It used to be when you installed IIS that everything was installed, then there was a lockdown utility that came out afterwards, to get you back into a little more secure environment. The approach they're taking now is let's install the minimum and then go back and you have to intentionally add things if you want to add more functionality. Like we've said throughout the course here, anytime you add more software and you have more things running, that gives you more exposure points. So you do want to be judicious when you're adding services. Server 2003 also has EAL Level 4 certification. The book does talk a little bit about Windows 2000. I don't really know anybody running that in production anymore. That was the successor to Windows NT. Server 2000 was also the first version of the operating system that came out with Active Directory, and I'm not quite sure what security levels those may have. Not all environments are going to be Microsoft based. There is a page worth of information here about hardening the Linux operating system. Linux is open source, which means that anybody can have the source code for the operating system. In some ways this can be a security vulnerability because it's pretty easy to actually read through source code, and if you're resourceful enough you can do testing and see what kind of exploits you might want to run. The book does say though that Linux and Unix, if they are configured properly, are actually pretty secure, and the trick is making sure that you do the proper configuration, and they mention running several scripts at startup to turn off things that are unneeded. There's an even more brief section discussing how to harden NetWare. I think I mentioned before, and the textbook tells you here too, that I think up through version 4 of NetWare the default protocol was IPX SPX. And I guess in version 5, that's when they switched over to making TCP/IP the default protocol. The book does say that in version 6 it was susceptible to denial of service attacks, and I assume that there were probably quite a few patches or maintenance packs that came out to address that particular vulnerability. There is a pretty short discussion about how to harden Apple Macintosh computers. The textbook says that these seem to be the most vulnerable to physical attacks through the console, meaning that you're not coming in through the network itself, you're coming in actually trying to sign in and hack in that way. It discusses the fact that there is a pretty simple password encryption scheme, and that the password file is actually located in a named folder. And so if you know what you're looking for, and 32-bit security really does not take a password cracker very long to get through. So that is an obvious vulnerability there. If what you're doing is actually network access, then it's about as secure as any other network-related access issue that you could have on any other operating system.